A very good morning, students. You are welcome to the channel bySeemaMakhijani, and today's class has got the topic extraction of metals or metallurgical processes. Now this particular chapter which deals with metals is found in class 8, then it goes to class 10 and then it also goes to class 12th. Fine. So I would be taking this topic in detail. So whichever class you are in, accordingly you can segregate the information that is required by you. Fine. Please do not forget to subscribe, like and promote the channel. Bless you kids. Let's begin with the class. The first thing, we are talking about extraction of metals. So we need to know details of the metals. For any details of the metals required, the information can be from the reactivity series. Now when I talk about the reactivity series, this is how the reactivity series looks like. The top of the reactivity series has highly reactive metals, and these metals are always found in combined state, which means chlorides, sulfates, sulfides, oxides. They will never be found in free state, and the reason is due to their high reactivity. Coming to the second category of the metals, this category is for the moderately reactive metals. Now these moderately reactive metals are also found in the form of compounds. Now generally the compounds are either oxides or sulfides. They are also carbonates, which means you would find them as zinc oxide, zinc carbonate, zinc sulfide, similarly iron oxide or lead sulfide, etc. Now generally out of them it is the oxides which are maximum. The question is why? Why are the metals generally found as oxides? And the reason for it is that oxygen is highly abundant, so it is freely available to react, and also highly reactive. So if you are asked why are generally the metals extracted from the oxides, or why are metals found as oxides in the minerals, the answer is you have 2 points. One is the abundance of oxygen, and second is its high reactivity. Coming down further lower, below hydrogen, you have copper, mercury and silver. Of course, as I go down, the reactivity goes on decreasing. These last two are never found in combined form, which means you will always find them in free form in nature. Therefore, the extraction is easy because they are in free form. In fact, you mainly require a refining process, which is the main agenda. We are also left with copper, mercury and silver. They are also found as oxides and sulfides, mercuric oxide, mercury sulfide, silver also as a sulfide. This you very well know. This we did during corrosion also. Silver articles turn black due to this silver sulfide formation. That was the details about the metals. Now coming to the details about the steps of extraction. Now this extraction we do it from minerals. Now what are minerals? The minerals are defined as naturally occurring metals, which when you are talking about low reactive metals, or metal compounds when we are talking about high reactive metals in the earth crust. Now since they are found in the earth crust, then in that case in a mineral you are bound to have two things. One is of interest, metal, or the metal compound is what you are interested in, and the second is It could have mud. It could have pebbles. It could have stones. It could have sand. All these together are given a special name as gangue, which is nothing but the earthy impurities present in the mineral. Fine? So, if you have a mineral, you have two things. This is what you need and this is what you don't. So, the first step in extraction is always to remove your gangue. Now, before I go to the metallurgical steps, I need you to understand something more about minerals. Now, if you have a mineral, there are two minerals. This is number 1 and this is number 2. Both of them have iron oxide in them. Both of them are iron minerals. This one has got iron oxide in 2%. So what is the rest 98% is your gangue. While this particular mineral, I had 12% of iron oxide. What am I left with? 88% is your gangue. Now if I have two such minerals, what will be your say as to where should I do the extraction from? The extraction would be done from which particular ore or which particular mineral. The mineral that I would be using for the extraction is going to be this one. Why so? The reason is this one has lesser gangue and more of the metal compound. Therefore, I would prefer that the extraction is done from this particular mineral. Whichever mineral you use, that particular mineral which you use for extraction is called as ore. Which means your ore is a mineral which has high percentage of the metal compound. So if the percentage of metal compound is high, that particular mineral is used for extraction, because if you have an ore, then your extraction is easy and economical, which means profitable. And that is the agenda. Why would you like to spend lots of money on extraction if you have an option? Why would I use this particular mineral? I would prefer this particular mineral. So the mineral from which you prefer to do extraction, because it is easy and economical, is called as the ore. Fine. Moving on to the extraction part. Now when I talk about the extraction, the process of extracting your pure metal from the ore is already been defined. So when you extract your pure metal from the ore, this process is called as metallurgy. This definition you should know, and you have steps for metallurgy. The first step is called as enrichment of the ore. You will find in other books, instead of enrichment, it's written benefaction, or it is also written concentration of the ore. Now what do we mean by these words? It is nothing but removal of gangue. And what is gangue? The earthy impurities. So if you are able to remove gangue from the ore, what are you left with? You are left with the metal or the metal compound. So the processes that you use for the removal of gangue come under the category of enrichment of the ore or benefaction or concentration. In class 10th you have only the statement, but as you move on to the higher classes, this enrichment of the ore or benefaction has got processes which we will do in class 12th is your magnetic separation, froth flotation process, hydraulic washing, etc. There are many, but right now I am not concentrating on them. Moving on to the step 2. The step 2 is oxidation of the metal. I had already told you, generally your metal compound is an oxide, but in case it is not an oxide, you have to convert it into an oxide because the extraction becomes easier from the oxide. Now let's say I have the metal as a sulfide, or I have the metal as a carbonate. So the agenda would be to transform my metal sulfide and the metal carbonate into its oxide. I have taken the example of zinc sulfide as the metal compound that I have and zinc carbonate. Now if I have zinc sulfide and I want to transform it into an oxide, what will I do? I would treat it in the presence of air, heat it so that I get zinc oxide. What will be the byproduct? The byproduct is going to be your SO2 gas. Just remember it. So this is your byproduct. Whenever you will have a sulfide ore, you will heat it in the presence of air, you will get your metal oxide, and the byproduct is the SO2 gas. Now do you remember how does this SO2 gas, any characteristic of this SO2 gas? Yes, the characteristic was it has the smell of burning sulfur. Fine. Now this process is called as roasting in metallurgy, which means it is applicable to sulfide ores. You heat it in the presence of air to transform it into an oxide, and the byproduct is a SO2 gas, which can be detected by its smell. So oxidation of the metal compound, if it is sulfide, the process is called as roasting. Moving on to the carbonate ore. If your ore is a carbonate, then what? In this case, you will only heat in the absence of air. So there's a difference. Here you only heat, there's no air, while in this sulfide ores you were to heat in the presence of oxygen. If you heat it, you end up in zinc oxide, and the byproduct is going to be your carbon dioxide. This carbon dioxide, can you test it? Can you identify the gas? Yes, you can. It will turn your lime water milky. That is just a piece of information. So in this case, this method is called as calcination. This is a commonly asked question, difference between roasting and calcination, and the answer would be roasting and calcinations are the step 2, that is when you convert your metal compound into oxide by either roasting or calcination. Roasting is applicable to sulfide ores, calcination is applicable to carbonate ores. That's point number 1. Roasting requires heating in the presence of air, calcination requires heating in the absence of air. That's the second difference. During roasting, the byproduct gas is SO2, while during calcination, the byproduct gas is CO2. That is the third difference. And fourth point, I would advise that you give the chemical equation. Fine. So you should know 4 points of difference between roasting and calcination. Fine. Moving ahead. The third step of the metallurgy is called as reduction. Here your metal compound is changed into metal. This step is called as reduction. If you remember, what was the meaning of the word reduction? Was minus oxygen. You have to remove oxygen. And how can you do this removal of oxygen? This removal of oxygen, you have multiple methods which we will be discussing in this particular class, where you will transform your metal oxide to metal. Now the first method to remove oxygen, we will be using methods like, one is only heating and the oxygen gets removed. The second is a reducing agent. The third is a stronger reducing agent. And if nothing works, then we will use the electrolytic reduction. So for reduction, you have 4 options to choose from. The first method, where we are going to use only heating, is applicable to low reactive metal like mercury. So if you have a mercuric oxide, you just need to heat it. Because it is less reactive, the bond is weak. By heating, this bond gets cleaved and you end up in your mercury and oxygen is liberated. So this gives you metal oxide changes to pure metal only by heating, is applicable for those metals which are low reactive. The second option for reduction is by using a reducing agent. Now this is applicable for middle order metals in the reactivity series. तो जो metals middle order reactivity series में हैं उनके लिए you would be using the reducing agent. Now in reducing agent you have two choices. The first choice is cheap, easily available and effective reducing agent, and that is carbon in the form of coke. This coke has a higher percentage of carbon in it. That is why we use coke. We would advise this because it is cheap and this will reduce the cost of extraction. So ideally it is always advised that you use the reducing agent carbon in the form of coke. While the second option, which is expensive, that would be used only if this does not work, is your reactive metal. You very well know what are metals? Elements which lose electrons, and those which lose electrons are acting as a reducing agent, and this reducing agent is aluminium. So when you are using aluminium powder as a reducing agent, this is not economical. This comes out to be an expensive method, so it is not generally advised. The example that I am taking is that of zinc oxide. Zinc is a middle order reactivity element. Zinc oxide reacts with carbon in the form of coke. You heat it, it transforms into zinc is what you are required to, and the byproduct is carbon monoxide. So your agenda was to obtain the metal and you have obtained the metal. This metal that you obtain in this process is roughly around 90 to 95% pure. You still need refining, which is generally the last step which I would be doing after this. So once you get your zinc in the third step, when do we use aluminium? This is a special method. When you use aluminium powder, the name of the process is alumino thermite process. Since it has a name, it has an importance and it is also asked in your exams. I would now be doing the aluminothermite process in detail. Now this aluminothermite process is used for manganese oxide. You treat it with aluminium powder. On heating, it gives you free manganese and aluminium changes to Al2O3. Now when do you use this? This is used when you cannot use carbon. Wherever the metal is reactive and this bond is strong, since this is a strong bond, here carbon is unable to remove oxygen, so you need to use aluminium. Advantage of this method is it is a method where a large amount of heat is liberated. The process is exothermic. That is why we use the word thermite, is due to this exothermicity of the process. This is also used, you can balance the equation. If I need to balance this equation, I would take this to be 4. This is twice. Your manganese therefore in this case comes out to be, oxygen is how much? 6 times. So I make this thrice, Mn comes out to be thrice. Coming to the second method, for aluminothermite process, you can also use it for ferric oxide. Ferric oxide solid is treated with aluminium powder solid, which is the reducing agent. This pulls away the oxygen, leading to free iron you get, and this along with you would get Al2O3. Now again, since there is a large amount of heat evolved, this iron that you obtain, due to this heat, the iron that you obtain is molten form. Similarly, due to this heat, the manganese that you obtain is in the molten form, liquid state. That is a special advantage of this method, that the metal is obtained in the molten form and the process involves a large amount of heat. The aluminothermite process, my advice, if you are wanting to learn only one equation, then in that case my advice is you do the second, because the second one also has a practical application in daily life. This is to repair the railway tracks. We use this method. Let's take this to be a railway track. This is your railway track, one of the railway tracks. and these are your bars in between. This is how the track looks like. Let us assume this iron railway tracks has developed cracks in it. Now, if there are cracks in it, then this needs to be replaced. Now, these cracks in the railway tracks can be repaired without removing the railway track. What do we do? You take aluminium powder and ferric oxide powder, mix the two and fill the cracks. Now, your cracks will be filled with this particular powder. Just leave it. There is no need to remove the track. Just fill these cracks with this mixture powder and let the other trains move on it. Now, when the other trains would move on it, there would be friction and they would be heated. Once the railway tracks are heated, the reaction will move in the forward direction. You would get iron in molten form, and this iron in molten form जो मिलेगा वो cracks को भर देगा. Your cracks would be filled up by this molten iron that you obtain, and this aluminium powder would be somewhere inside the cracks. We are not concerned with it because of the large amount of heat due to friction. This heat would be due to friction when the trains travel over the tracks, and the iron that you obtained would be in liquid form. It would easily fill up your cracks without removing the tracks. Moving on to the last step, which is the third option, which was using reduction by electricity. Now, when would you use reduction by electricity? This method is only used for highly reactive metal compounds, and you directly change it to the metal by passing electricity through it. Supposing your metal compound is sodium chloride. Now, for this sodium chloride, you will not transform into sodium oxide because it is highly reactive and it will explode. You cannot reduce it by using a reducing agent because this does not happen because this bond is very strong. That means you cannot use carbon. You can also not use aluminium because aluminium is less reactive than sodium. So, the reaction will not happen. Therefore, the only option that you are left with is a stronger method of reduction, which is by using electricity. Fine. Now, this is a ionic compound. Ionic compounds conduct electricity, but they conduct electricity only in molten or in aqueous form. You will be using sodium chloride in molten form. I'll give you the reason later why not aqueous. This molten sodium chloride, you pass electricity through it. When you would pass electricity, it would decompose into its respective ions, sodium ion and the chloride ion. And now these ions will travel to the respective electrodes. So, we will see that in the cell you would have a cathode, which is your negatively charged terminal, and the anode is called the positively charged terminal. Towards the negative charged terminal, which ion would go? Sodium, of course. So, your sodium ion goes to the cathode, undergoes reduction by gaining electron and becomes sodium, gets deposited here, and your agenda is accomplished. आपको sodium मिल गया because by passing electricity through NaCl on the cathode, you always have reduction, and by reduction I mean gain of electrons, and you get sodium deposited, which you can collect. What happens at the anode? Anode is the positive terminal. Always at the anode you have oxidation happening. Oxidation means loss of electron. So, at the anode you would have Cl minus. It would lose electron to become Cl. You very well know Cl does not exist alone. Two Cl atoms will combine together to give you chlorine gas, and this will be liberated at the anode. So, the agenda was for reducing highly reactive metals, use electricity, and at the cathode you will get your metal obtained. Fine. Moving on to the last step, which is refining of the metal. Your metal obtained till now is 90 to 95% pure, and you want this metal to transform into 99 to 100% pure. And for this, the method that you have in your syllabus is electrolytic refining. And the metals for which you should know that this can be done is, one is copper, which I have done in detail in my video of the YouTube channel. Please refer to my channel to the playlist of metals and non-metals. You would come across the video which has the electrolytic refining of copper, but the same method can also be used for zinc, exactly like I did for copper. You can also do it for zinc. So for purification, you use the method of electrolytic refining, which is already done in detail in one of my videos. I hope you have understood the steps of metallurgy. This is one of the important processes and the questions for evaluation. Please do it in detail. You should know that there are 4 steps in extraction and the detail of each and every step should be known to you. Is that fine? With this, I end the class on metallurgy for class 10th. Wish you all good luck for your exams. Stay well, stay healthy, remain connected, and please don't forget to like and subscribe.